So we're now sort of transition into sort of the Q&A part, slightly moderate discussion. Yeah, so I'll just kind of try to pick and choose some of the questions that folks have been posting here from through our speakers have been presenting. So will there be, for example, accommodations on how the EVA crew will gauge range and features, right? While using the rover vehicle. So this is probably for Mike. Do we lose Mike?
I think he may no longer be on.
I'm sorry?
He's no longer on.
Oh, okay. So we lost Mike. Okay, well then let's move on. This one's for Mary. So have there been intentions of adding like haptic feedback to the gloves?
Pardon me, I caught just part of that. Could you repeat?
Yeah, so are there any intentions of adding like haptic feedback to the gloves that the astronauts are going to be using?
I would be happy to take that question back to the XEMU program and return an answer.
Okay. So for this one's kind of for Ian. There was one question about how high is the I guess will the astronauts have to climb down from the I guess from the module to descent down to the surface?
Yeah, I responded in text to this one. I can't say exactly how high it is. It is tall, I will say that much. We've already performed testing on the ladder system in the neutral buoyancy lab down at Johnson, including in some off nominal slope conditions. So we've got positive feedback from the crew on that. In addition, there are other requirements on HLS that necessitate the need for a backup method for ingress egress. So we have that, but I'm also not at liberty to discuss that today.
Okay. Yeah, no, thank you for sharing that and answering in the chat. I missed that. So I guess the next question is for I guess Gary, in terms of what kind of what kind of issues do you anticipate seeing in terms of as transporting lunar dust back from the HLS that astronauts are going to be bringing back, and how are we going to be able to make sure that we keep the dust out?
Well, I think if you're talking about the sample return, I think, the key there is just doing a good job making sure that it's, hermetically sealed before we enter into the gateway. I mean, we are concerned about that, but we don't right now envision doing anything with the samples on Gateway, but just being a conduit to get it from the lander into Orion. So I think just keeping it all sealed up, and we're probably more worried about dust coming off of the EVA suits or the tools, and again we're going to work to clean those as much as we can before we even get into the lander. Clean them again in the lander before we get into Gateway. So it's this, multi-step process, but we're still worried about, dust still being stuck to those suits that could be liberated, inside a Gateway. So we are developing tools to not only to filter the air, but also to, clean dust off of suits, vacuums and wipes and things like that to clean off of surfaces.
Okay, great. Well, thank you, Gary. I guess a question for Michael is, are there going to be other opportunities potentially for investigations to on CLIPS missions to do either technology demonstrations or to look at some of these dust effects?
Yeah, so the CLIPS program is an ongoing program. They frequently put out calls, or every so often put out calls for new payloads. So if you have something in mind, you can potentially use the LSIC to form partnerships and put together a payload package.
Okay, great. Thanks, Mike. Okay, and then maybe I will have just maybe one last question here in terms of, so I guess for Jerry, right? You're talking about these gaps that you outlined here, and so I didn't see sort of dust highlighted as one of the ones. So, or do you think that that's not as much of an issue as compared to some of these sort of thermal effects that you highlighted in your presentation, or are there others?
Say the question again. I mean, obviously we have to deal with regolith for different applications. I didn't specifically call out power or thermal because to a certain extent those are covered by other folks, and I would recognize that if we have a rover excavator, for example, that whatever radiator or whatever power system would need to deal with that. So from our perspective, we're looking more at the how do I understand the regolith? How do I pull that material out and transfer it? How do I process it? And what is that material doing to our hardware throughout that phase? And we do recognize that when it comes to traction and gears and motors, that obviously we're in intimate contact with the regolith. So our mitigation techniques or our designs will need to take that into consideration a lot more potentially than some of the other surface systems.
Okay, great. Well, thank you, Jerry, and thank you to all the other speakers. Again, thank you so much, and for the great questions that we've gotten. Yeah, if folks want to, some of the speakers want to look at the chat box and the Q&A, if you think you can answer some of those questions, that would be fantastic. So just to try to keep us on track, so we're going to shorten a little bit the break, and we're going to take a break here. And reconvene in roughly 15 minutes at 1:40, where we will have our lightning talks. So thank you again to all our speakers this morning, and thank you for bearing with us, as of course, with the technology. And trying to do these types of events with virtually. So, but this was very exciting, and really appreciate the talks, as well as your insights in terms of what some of the needs that the speakers identified in terms of these architecture elements. Okay. So yeah, so just again, we're going to reconvene at 40. We'll have a sort of 15-minute break, and yeah, we'll resume with our lightning talks. Thank you so much.